Solid Edge continues to set the standard for streamlining 3D design. In ST5, modeling with synchronous technologies is even faster and more flexible. In this demonstration, we'll work with an industrial snowblower. ST5's hole recognition functionality recognizes holes resident in the imported models, converting them into synchronous features. Holes can be identified for an entire model or a single face. Here we'll use face selection on this imported gear housing to grab all the holes and edit their size at once. Here we're going to modify the 10 simple holes into threaded holes. We're going to change the simple hole to a 12 mm threaded tapped hole. Now watch as we use the same technique to change the type for a series of holes on these other two faces. This time we're going to use hole recognition to modify the simple holes to counterbore holes. Finally, we'll run the hole recognition command one more time to recognize all of the other holes in the entire model. Watch as these hole features get added to the Pathfinder. Now we'll save our imported model. This is the gear housing that's actually used in the snowblower machine. Let's take a look at what that snowblower machine looks like. Advances in part and sheet metal modeling in the context of the assembly environment greatly increases the efficiency of our design efforts. Features can be added and edited and deleted while working within the assembly, often without having to in-place activate into the part. ST5 part and sheet metal features can be located within the assembly using face priority. Watch as we use this functionality to modify the pattern of holes on the auger assembly in order to match the changes we previously made to the gear housing. Within an assembly, several new options for replacing parts, sheet metal parts, and subassemblies are available in ST5. A part can be replaced with a standard part, a new part, or copying of an existing part. We use replace part with copy to replace the middle flap assembly with a copy. We simply give it another name. Now within this copy, we're going to make a copy of the red flat part to form a new unique part. Essentially, we're forming the basis for a derivative design of the middle flap assembly. We can see this part within the context of the overall assembly. Now watch as we widen the new middle flap using synchronous technology. We're also going to add a new body of the logo for our company. We're going to add this as a construction body in our part. This is using the multi-body functionality in ST5. If we look in Pathfinder, you see we have our design body and our construction body. We'll relocate our construction body within the part using synchronous. Again, we'll use the Boolean commands to Boolean the logo out of the red flat part. Using Part Painter, we can bring out the detail of the Schmidt logo. Now we'll return back to the top level assembly. and we can change our configuration to turn parts off. The increased flexibility of ST5 speeds modeling by permitting synchronous modifications of parts and sheet metal within the assembly environment. Here we're going to focus on the plow's drag wheel assembly and add flanges without selecting any sheet metal command, which is fast and efficient. Now we'll actually go into the sheet metal part to make some other changes to it. The first thing we do is close the corners. We want these corners to be welded together. Close corner command is an obvious process-specific command in our sheet metal environment. Now by adding a dimension to the width of the entire bracket, we can change it symmetrically using the new option in ST5 to move symmetrically. We're going to make it slightly smaller. Solid Edge also captures the intent of a particular edit with the dimension. Notice the arrow is pointing to the left automatically, because the last time it was edited, it was changed to the left. In the case of the height, there is no option. The reason there's no option is because there is a fixed relationship on the bottom of the bracket. So the only option is to move that dimension up or down. The plow's operator needs to pivot the drag wheel up and out of the way. So what we will do is place a slot feature on the wheel bracket. Now we'll return back to the pivot wheel assembly. Solid Edge assembly provides a powerful path relationship which allows a part to follow a path, either planar or 3D. In this demo, we'll add a path relationship between the wheel assembly and the slot. As we drag the assembly, notice how it is constrained to follow the slot. In ST5, another extremely powerful and efficient use of time is realized when part features are added while working in the context of the assembly. Watch as we use an assembly feature to create holes in the corresponding parts. We can include 2D geometry from the part itself. We use this to locate the pinholes that are going to go through the bracket and the plate. After we've determined their location, the next step is to determine which parts will be cut by those holes. We only want to cut the bracket and the plate. We no longer need the sketches, so we can hide those. So here we can see the two holes that we just placed. These holes actually get pushed down into the part file. So let's edit the plate just to see. Here you see the holes were added to the end of the feature tree in Pathfinder. Next, we need to place this wheel on the opposite side. We use Solid Edge's assembly mirroring capability to mirror the features and components to the other side. We simply select the assemblies that we want to mirror and mirror them about a center reference plane. Solid Edge is very powerful in that it can determine based on the geometry whether a part needs to actually be physically mirrored and create a new part, or if the part can just simply be rotated into the new position. Once we click OK, Solid Edge will create any new files that it needs to create for the mirrored components. Associativity in mirrored assemblies is a huge productivity enhancement in ST5. Here we'll move the original drag wheel assembly and watch as the mirrored copy moves accordingly. The final thing we want to show is what if we wanted to change a component in the original drag wheel assembly. Let's focus in on the original drag wheel assembly by editing it in place. Here we want to replace the adjustment wheel with a new design. Again, we use the replace part functionality and we'll find the part on disk that we want to use to replace. Solid Edge uses geometric matching to reestablish the relationships between the new wheel and the existing assembly. Now as we look at the mirrored copy, you see it appears to be missing. This is simply a case of where the mirrored subassembly needs to be updated. Solid Edge ST5 increases synchronous modeling flexibility, makes designers more productive, and significantly reduces development time and costs. Shorten your time to market and strengthen your bottom line. With Solid Edge, we help engineers design better.